In this video, we're going to focus on continuous time convolution. As we've talked in the first video in this portion of talking about continuous convolution, we talked about the fact that the convolution is used to convolute the input with an impulse response, convolute x of t with h of t, and mathematically how we do that is this integral. And then we also talked about the fact that we have two ways of dealing with this integral to come up with a equation or a graphic representation of y of t, and these two approaches, one is called the graphical or intuitive method, which allows you to draw unique intervals where you can write an equation and you use the graph to help you guide you to where and what to write in your equation. The other one is this method we're going to talk in this video about. It's basically applying mathematics, and let our knowledge of mathematics and analytics guides us through the whole thing without needing to graph or intuitively see where the overlap, partial overlap, full overlap is. Let the mathematical constructs guide us through that. So let's go ahead and take a look at that. In here, I've written the integral, convolution integral, and now all we have to do is go in there and plug x of t and h of t minus tau. Now the problem statement has given us x of t, so all we have to do to make x of t, x of tau, is basically everywhere we see a t, replace it with tau. So in order to do that, so let's go ahead and, so it's going to be from minus infinity to infinity still. X of tau is going to be basically 2e to the minus 5 tau u of tau. Okay? And then in order to take h of t and turn it into h of t minus tau, we basically take everywhere we see a t and we replace it with t minus tau. So if we were to do that, then we are able to write, let's say this is x of tau. Now we're going to write h of tau, which is going to be basically 4 unit step t minus tau minus 2, and then minus u of t minus tau minus 5, and that 4 is multiplied by both of those guys, and that, and we know this integration is with respect to tau. So let's see what all these different things are telling us. Basically, let's break them down one at a time. This u of tau is telling us that this thing is non-zero only when tau is larger than 0. So that's great. So one condition is that this integral really doesn't play a role unless tau is greater than 0. So that by itself lets us know that we can throw away half of this interval because it's going to be 0 and we don't have to worry about it. So y of t will get reduced to minus infinity to plus infinity, 2e of minus 5 tau. We don't have to put u of tau because instead of saying goes from minus infinity, we just say it goes from 0. This way we can, that does the job of u of tau. So now we're still left the 4 and the 2. Actually, we can take both of them out, but for now, let's leave them in there. The next time I'll take them out. So 4, and we still have to deal with u of t minus tau minus 2 minus u of t minus tau minus 5. Now we got to figure out how to deal with these two items. We know that the tau, but this is a little different because you got t in here. So what we can basically say is that this thing is 1 only if, right, t minus tau minus 2 is larger or equal to 0, which means tau has to be less than or equal to t minus 2 when we clean it up. Okay, and then we also notice that this piece, you see these are subtracted from each other, so if you look at this thing, this basically says this piece, it's 1, otherwise 0. Only if tau is less than or equal to t minus 5. Okay, and you notice these are getting subtracted from each other, so that's kind of limiting our range, which basically says our range for whatever we are doing, t goes from minus 2 to minus 5, and that's all it does there. So the d of tau, I forgot to put in here. So this can further simplify our y of t by simply saying that y of t is basically an integral where tau goes from t minus 2 to t minus 5, 8, because this goes away, and you got 8 e to the minus 5 tau d tau. So we were able to simplify this further, but this has a lot of hidden things in it. For example, we have to make sure that whatever the value of t is, this function is only evaluated from t minus 2 to t minus 5. And we also have to remember that the tau below 0 is always going to be 0, so we won't have any functions there. So there's even though this is a nice simple equation that comes up, there are lots of background that we have to have and think through, because remember, we basically said that tau, these are taus, so the taus cannot be less than 0. If they are equal to 0, then y of t is going to be equal to 0. So here is basically, in summary, here is one equation that we could use in conjunction with the understanding of step response instead of doing the graphical method. Okay. The one thing it doesn't do, the mathematical method doesn't do for us, is gives us a perspective of what the function looks like as we are working through it. When we were doing graphical or intuitive method, you could literally see what was going on as you're working through it. One minor correction I should make at this point is that this really, if you're going to write it correctly, this should be from t of minus 5 to t of 2. And as I mentioned earlier, when you write a integral like this, you're basically saying tau is going from this value to this value. But remember, tau, when tau is less than or equal to 0, this equation, this thing is equal to the whole integral is equal to 0. Remember, because why? Because remember when we did away with this one, that was the rule that allows us to do away with that one, because we agreed to the fact that the integral sum is equal to 0 when t is less than 0 for that. That basically tells us that t minus 2 must be larger than 0, and then actually this is less than 0, not less than 0. So that must be larger or equal to 0, and also t minus 5 must be larger or equal to 0. So those are the conditions you have to keep in mind when you're using y of t to evaluate this. Okay, if for example from here, if this is not valid, then y of t is equal to 0, or if this is not valid, y of t equal to 0. So those are important things for you to consider as you're working through this set of equations. And that what makes the mathematical side harder to conceptualize. If you had the graph, it would be really obvious. And you can go, the same problem was solved in the previous video, so you can go back to the graphical approach and see how that got done. Okay? And that brings us to the end of the discrete time, continuous time convolution example using mathematical approach.